Hello and welcome back to Zig's Math Lessons. The derivatives of polynomial functions. Differentiation means the process of determining the derivative or figuring out the derivative. Rules for derivatives. The derivative of a constant is 0. So dB by dx equals 0. So here's why. Here's a picture of y equals 3, this blue line. Well, we can see that this blue line doesn't rise. So rise over run will always be 0. The slope of a horizontal line is 0, and y equals 3 is a horizontal line, so the derivative of a constant is 0. The derivative of a multiple of x is the multiple, so derivative of mx is m. And this is true because the slope of y equals mx plus b is m. And we know that a derivative is the slope. So d5x by dx equals 5. More rules for derivatives. The multiple rule. The derivative of a multiple of a function is the same multiple of the derivative of that function. What this means is, if f of x is a multiple of g of x, so if f of x equals k g of x, then f prime of x is k times g prime of x. The power rule for differentiation. This one's a little strange, but if y equals x to the exponent n, then dy by dx, or if you prefer, y prime, or f prime of x, they all mean the same thing, the slope function, dy by dx is, the n comes out front, and then it reduces by 1. It becomes nx to the n minus 1. For example, if y equals x to the 3, then the derivative of y is 3x squared. The 3 comes out front, and the 3 reduces by 1. Let's get some practice with this. On the left side here, I have several functions, and on the right side, we'll fill in the derivatives, f prime of x. So if f of x equals x to the 5th plus x to the 3 plus x to the 2, then f prime of x is, the 5 comes out front and then reduces by 1. So 5x to the 4, and then 3x to the 2, and 2x to the 1 with these signs. This is the derivative. And amazingly enough, this is the limit as h approaches 0 of f of x plus h minus f of x over h. We can predict it precisely without having to do the onerous work of figuring out what is f of x plus h, which would be quite difficult to do. Well, it would be a lot of work. The rigorous proof of all this is left for other calculus courses. Let's go next. Y equals 2x plus 1. Well, we know from grade 9 that the slope here is 2. We also know from the rules that derivative of mx is m. Let's go next. Y equals this polynomial function. Its derivative will be 5 using the multiple rule. 5 times 4x to the 3, etc. Minus 3, the same multiple, times 2x to the 1, using the power rule. Plus, well, this is mx, so plus 7, and this is a constant, so plus 0. Now, of course, this is 5 times 4 is actually 20, and this is minus 3 times 2, which is actually minus 6. And we have that for a derivative. We might notice the pattern here. The 4 kind of hops over and multiplies with the coefficient and becomes 20x to the 3. See it there? The 2 hops over and multiplies with the coefficient becoming minus 6x to the 1. There it is. And there's our mx differentiated. Using that pattern, We can now skip this step and just state the derivative when we see things like this. So the 2 hops over and it'll become minus 24x to the 1, etc. Minus 45x to the 4. Look at the pattern. Let's do some more practice. 9 times 8 is 72, x to the 8. Minus 42, x to the 6. And 8 times 12 is 96, x to the 7. Now it also works when the exponent on x is negative. Just be sure to subtract 1. So that minus 3, when differentiating, will become minus 4. So this becomes 28x to the 3 plus, because we're going to say minus 3 times minus 2 is plus 6x to the minus 4. And the derivative here is 0. Dwell on this one for a bit. 28x to the 3 plus 6x to the minus 4. And see where it all came from. Here we have one that has a fraction in it. A fractional exponent, that is. Yes, it still works with fractions. We have to be able to subtract 1. Here we go. 3 times 5 is 15x squared. It'll be minus 4/3 x to the minus 1/3. Because this 2/3 comes over, multiplies by 2, becomes 4/3 minus 4/3 x. Subtract 1 from 2/3, you have minus 1/3. And then subtract 2, because there's mx again. Now the minus sign on the exponent, we know from previous grades, puts that factor x on the denominator, and the fraction in the exponent creates a root sign, a third root sign in this case, because the denominator is 3. So we see that x ends up in the denominator under a third root sign because of this negative 1/3 exponent. How do we deal with this one? Well, let's differentiate. But first, I see x to the 4 in the denominator. Let's boost it up to the numerator and put a minus sign on it. Maybe it'll be easier to understand if it's here. Now, using the power rule, it'll be minus 4 times 5 is minus 20, x to the minus 5. And now the x to the minus 5 goes back to where it came from, the denominator, because the minus sign on the exponent puts it in the denominator. We can differentiate this if we understand that root x is really x to the 1/2, and put it into that form. This is 3x to the 4 plus x to the 1/2. Now differentiating is easy because we'll go 4 times 3 is 12x cubed, and it'll be plus 1/2 x to the 1/2 minus 1 is minus 1/2. And again, the negative sign in the exponent on the x puts the x in the denominator under a root sign. Here it is going to the denominator. Here it is going underneath a root sign. And there's the derivative of this function. This would be the limit as h approaches 0 of f of x plus h minus f of x over h. Quite an exercise when you think about it, and one that I'm glad that I don't have to do right now. Moving on. Differentiate. Well, we're not quite ready to deal with this as it stands, but we do know how to square a binomial. So before we differentiate, let's do some work on it. Let's square a binomial, which means 3 terms in here. The first term squared, double the product, so minus 15 doubled is minus 30x plus 25. Now distribute the 2. We haven't done any differentiating yet. We've just prepared to differentiate. And now we're ready to differentiate. it'll be 2 times 18 is 36, and so on. 36x to the 1 minus 60. The derivative is really quite easy. It's putting it into the form, getting it ready to differentiate. Sometimes takes a little work. Example. Find x values where this polynomial function has horizontal tangents. This is a cubic, and so we know that it will have, or probably will have, points where the tangent is horizontal. Solution. Horizontal lines have a slope of 0. So we'll set the derivative equal to 0 because the derivative is the slope of the tangent. So we'll have to differentiate it, which is easy. 3x squared minus 10x minus 8, and set that derivative equal to 0. This is a common theme in calculus, setting a derivative equal to 0, because it shows us where the tangent lines are horizontal. And those are interesting points. You'll see why later. But right now we have to solve this quadratic, because we've set this derivative equal to 0. Now, of course, you can use the quadratic formula, or we can factor. Let's factor instead. Because there's a coefficient on the x squared besides 1, we're going to use what's called tall brackets factoring, which means we make tall brackets and put 3x in the top left corners. Tall brackets with 3x in the top left corner. Now think of two positive whole numbers. Positive whole numbers that multiply to not 8, but 3 times 8, which is 24. So we'll put positive whole numbers in the top right-hand corner of the tall brackets. But these particular ones that multiply to 24 have to subtract. Because this sign says subtract, they have to subtract to the number 10. So that won't be 6 and 4, because 6 times 4, while that's 24, and while they do add up to 10, it won't be 6 and 4. It'll be 12 and 2, because the numbers have to subtract to 10. Not add to 10. And now put signs on them so that we end up at minus 10. That'll be minus 12 plus 2. And now the reason the brackets are tall is because you can always do this. Divide off a number from one or both of these factors. Now I see that 3 comes out of both of these, so I can divide off 3. And so dividing this factor by 3, we get x minus 4 times 3x plus 2 equals 0. And from grade 10 math, we know that therefore x equals 4, or negative 2/3. And these are x values where the function has horizontal tangents. Exercise in math. Begin by using first principles to differentiate this function. Then use the rules to check and see if you did it right. Okay, let's do that. We'll have to take the limit as h approaches 0 of f of x plus h minus f of x over h of this original function, subbing in x plus h both there and there. 3 times x plus h squared minus 5 times x plus h minus f of x, so minus square brackets and copy in all of it here. The brackets are needed because it reminds us to distribute the subtraction. That's the purpose of these brackets. And now we'll have to square and triple in one step perhaps. X squared times 3. Double the product, which is 2xh times 3, which will be plus 6xh. And h squared times 3, plus 3h squared. Distributing the minus 5, minus 5x, minus 5h. Distributing the subtraction, minus 3x squared, plus 5x. And we always at this stage get some offsetting. These offset, and these offset. And after we've done the offsetting, we'll always notice that h can be factored out. So common factor out the h out of the remaining terms in the numerator. H came out. It was common to each term. H now cancels. And after this, we can take the limit. Subbing in 0 for h, this term vanishes. We get 6x minus 5. And if we tried it using the rules, we'd have to start here. And the 2 jumps over times 3 is 6x, and this is mx, so this is minus 5. So they both end up with 6x minus 5. It's just that this one takes a little bit less work than this one did. If you like the content, please subscribe and tell your friends and help me grow my channel.